to look into is fabric. And the answer I got to was that synthetic fabrics are basically fabrics designed through chemical processes in which monomers are extracted through machines and chemically synthesized to make useful polymers. The examples I looked into for my project were polyester, nylon, and Kevlar. But the production of these chemical structures leads to all of them having beneficial properties, such as being stronger, being able to resist abrasion, which usually comes from one of the monomers, while the other monomer present in them usually contributes to the bonding to the actual materials being bound together and like not breaking apart, I guess, and higher strength or extension. And more often than not, these properties also lead to some disadvantages, such as higher flammability, which I looked into, and it's not necessarily flammability, but rather just um, like bonds breaking. So then I have to look into what exactly these monomers are. So they're basically just small individual molecules that serve as the building blocks for polymer chains. And as a polymer, which is a large molecule composed of these monomers, these synthetic fabrics are usually created or are created by polymerizing monomers to form long chains, which then undergo uh, processes to produce fibers that can be woven or knitted into fabrics. So then these are some examples of uh, the fabrics that I looked into, with the first one being nylon, the second one being Kevlar, and the third one being polyester. So then the main question that I wanted to look into was that how exactly does chemistry play a part in these fabrics and the way that they are used? So the first one that I looked into was Kevlar. So um, sorry, I had a little bit of so basically Kevlar has two major monomers or two monomers that play part into it. The first one, which I'm going to attempt to pronounce, is terephtol chloride, or in other words, TPC or TPCl, which basically is a high strength synthetic fiber with which provides the which provides Kevlar with pretty good or really good tensile strength, heat resistance, and durability, and it serves as a vital component in the synthesis of Kevlar by reacting with a diamine, which we'll see in the second monomer, to form a strong and durable polyamide polymer. The second one, I'm not even going to try to read the first part, which is usually just referred to as a um, PLD, contributes to the structure and properties of Kevlar fibers. It acts as a diamine component, as mentioned before, reacting with the TPC to form amide linkages. Linkages. Yeah, these linkages create a highly ordered and rigid molecular structure, providing Kevlar with exceptional tensile strength and thermal stability, as mentioned before. This leads to Kevlar being used in various applications, including bulletproof vests, body armor, uh, protective clothing, those three are kind of the same stuff, aerospace materials, and other demanding applications where strength and durability, what Kevlar is usually good for, tends to be crucial. The next one that I looked into was nylon, which tends to be a more common fabric, and this one also had two monomers that go into it. The first one being adipole chloride, which is a polar molecule. So it doesn't necessarily do that well in water. If CO bonds, when in the present, like water, breaks apart, but this leads to nylon being easily degraded, at least physically in presence of liquids. It tends to be one of the disadvantages of nylon. But the second one, it has a really long name, but it's usually shortened as HMDA, is a chemical compound that is used to synthesize nylon, a synthetic polymer. Nylon belongs to the polyamide family of substances and is widely used in a variety of applications, including technical plastics, automotive parts, electrical installations, carpets, and textile products. HMDA is a compound with the formula C6H16N2, discomposed of a chain of six carbons with an amino group on each end, or NH2. HMDA is among the monomers that are used to make nylon in the manufacturing process, and the nylon polymer chain is formed in a condensation process, which involves the use of HMDA and or adipic acid, which is another name for the first uh, monomer that I looked into. In this process, a repeating unit is formed in the nylon chain, and the combination of HTMA and this acid creates a polyamide structure. The characteristics of nylon as a whole are influenced by the presence of HMDA in its chain. It contributes to the exceptional tensile strength, durability, and abrasion resistance of nylon, and the qualities of nylon produced are also influenced by the length of the HMDA chain. Utilizing various monomers such as HMDA, numerous nylon variants are produced, including nylon 6 and nylon 66. Um, like I was mentioning earlier before, like one of these monomers typically leads to like the better properties or the properties that tend to be like the reason why people are looking into these fabrics. And in this case, HMDA is the one for nylon, as that is the one that is leading to to the strength, durability, and resistance of the fabric. Um, and going on to my third um, uh, fabric, polyester, which also contains two monomers. The first one being dicarboxylic acid, sometimes referred to as terephthalic acid, or C6H4CO2H2. It derives from benzene and has two carboxylic acid functional groups, and the rigid aromatic structure of the acid contributes to the strength, stability, and durability of resulting polyester materials. And the second one being ethylene glycol, which has the formula C2H6O2, which also contains two hydroxyl OH groups and one on each of the carbon atoms, which gives the polyester structure features such as flexibility, suppleness, and resilience. Uh, this is what I looked into, and then my last slide just contains the sources that I used. Thank you for listening, and I hope you liked my presentation.